Okay, oh my gosh, sorry about that. So I'd like to know, I want to talk about whatever you guys want to hear about. So I kind of want to know who I've got in the room. How many of you are Flex 8,000 customers? Okay, so there's a few of those. 6,000 customers? And how many of you do not have a Flex radio? Okay, so there's quite a few of those. So this is kind of default. What I would talk about is spend some time talking about what a Flex radio is, what an SDR is, why you'd want to buy one of our radios, and then talk about our current radios, the 8000. And then at the end of that, get into a software roadmap and where we are. The software roadmap and all that's going to be important for folks that have a Flex radio, whereas all the front material is more important for people that don't have one. So we're kind of a 50-50 mix here, so I'm going to go through this, and I apologize to each group that, you know, there's kind of a little of both all this in here. If you guys want to stop me at any point in the discussion here, feel free to do that, and I'll answer questions, and we'll take some at the end as well. Okay, so who is Flex Radio? We were started in 2003. We're an Austin, Texas company. We build software-defined radios, and we have an installed base of roughly 30,000 radios. So we're not the biggest supplier of ham radios, but we do focus on HF, and it is a substantial portion of our revenue. That's what we do. So what is an SDR? If you look at a traditional radio, a radio is going to have an antenna that goes into a mixer, and you have a local oscillator that is what you use when you're turning the tuning dial. That sets the frequency that goes into a mixer. You get the sum and the difference of both of the frequencies, the LO and what you're taking off the antenna, as well as both of those. So you filter it, so all you get left is what's called the intermediate frequency, or the IF. Feed that through an amp, you do demodulation, then you put it out through an audio amp and out through your speaker. So this is a very, very basic block diagram of what a regular radio would look like. So what are the drawbacks in having an analog radio that all those pieces are capacitors and resistors and mixers and all that? The demodulation and modulation in a radio like that requires a separate circuit for each kind of modulation because they're not flexible and you can't change them out. You can't easily add a new modulation scheme or a new mode after you've bought the radio. Your bandwidth in the particular mode you're using is typically restricted based on your IF bandwidth. And then if you have multiple heterodyne stages or multiple mixers, those add noise and distortion over time. Now, a super heterodyne radio, which is what most of the analog radios you can buy today, have either 2 or 3 stages of mixing in them. And they're fine radios, but they do have more distortion than a radio that doesn't do that. So what I would call a true SDR. So let's talk about what that is. So at some point, the guys that built super heterodyne radios said, let's pull out the demodulation step that happens in analog electronics and put in digital electronics. So the blue blocks I have here now are digital. So we take the intermediate frequency that comes out of our filter and our amplifier, we do analog to digital conversion on that, we turn it into a bunch of numbers, then we can do our demodulation in our baseband filtering inside of a microprocessor, put that back through a digital to analog converter and play it out the speaker. So now this thing allows us to go change the modulation scheme and some of those sort of things. So you get modes you can base on software, you can get dynamic filtering out of this where you can adjust the filtering bandwidth and the type of filtering. You could put multiple receivers in a fairly narrow bandwidth, which would be your IF bandwidth. So there's some of the manufacturers that have done that, and there's some novel names for doing that. So question is, could we do more? And this is what an SDR is all about, which is taking all this stuff on the front, your analog mixer and your filter and your amplifier, and turning all that into digital. So this is what I would call more of a true SDR, where we take on the antenna, we put an analog to digital converter. Now, there might be some amplification or some attenuator on the front to deal with large signals, but pretty quickly we do analog to digital conversion, and then we place all of our mixers in digital electronics in an FPGA or doing it with mathematics. And there's a lot of benefits to doing this. One of them is you get minimal distortion because you very quickly go from analog to digital, and once you're in the digital domain, if you treat the numbers properly and you don't do rounding errors and bad math and things like that, it's pretty much perfect all the way through and you can do whatever you want. Another really cool thing you get out of that is you can have as many receivers as you want. In the analog world, if you want to use multiple receivers on the same antenna, you have to split the RF signal. You lose 3 dB when you do that, and then you add other distortion, and there's all kinds of problems with that. In a radio like this, you just make a copy of the number in software. So you can have as many receivers as you want. We are also able to do a fast Fourier transform or a conversion from the time domain into the frequency domain and show you a frequency plot of the spectrum, and we can make that as wide as we want, which is really nice. You could show a whole ham band with that. We have very high dynamic range, and this is just a function of the analog to digital converters used. We do get a lot of flexibility through reprogramming. So I might decide today that I want my intermediate frequency to be, or the frequency I do all my final filtering at to be 20 kilohertz, but tomorrow I might say, we have a new feature and we want to make it work at 100 kilohertz. And we can go change all that through reprogrammability. These kind of radios are more challenging to design, and it is a completely different engineering team. So if you had a company and you were doing analog and you want to switch to digital, you kind of need new people, or they all got to learn new stuff. All right, so this then is what a direct sampling SDR looks like. You got a knob, but the knob just changes numbers in the numerical part of the radio. It no longer changes the oscillator. But this is the cool thing we could do, is we can go add an additional receiver in there. So we can literally put as many of these receivers in here as we have the processing power to deal with. So this is a diagram kind of the internals of a Flex 6000 or 8000. They're fairly similar in the architectural design. And we have an analog section, which are these things that are said SCU that have the dotted line around them. And they have some filters on the front, preamp attenuation, but then it goes to the analog to digital converter, and after that, everything is analog. You do have an oscillator in here, but your oscillator is now what's called a sampling clock, and it feeds into the ADCs, which give you the receiver, and the digital analog converter, which gives you the transmitter. But it's a single frequency, and you can make that a very fine oscillator that's better than you typically make with a variable frequency synthesizer. Any questions on that before I go on? All right. So this is what the console of one of our radios looks like. So we can put a lot of bandwidth up here. You get a lot of control all in software, and all this stuff can be shipped over the Ethernet, so you can control the radio easily without having to twist analog knobs or anything like that. This is another example showing two bands at the same time. In this case, I happen to have 20 meters on both of them, but they could be different. So why do you want to buy one of our radios? Well, there's a lot of them on the market. They're all different, all have different capabilities. So let's talk about what we do that's different. One of the things we do is we have the best remote capability in the business. And we've done that because when we designed the Flex 6000, we designed it from the ground up to be a remotable radio. Everything we do in that radio thinks about remote. So when we ship bandwidth over the radio to put up displays or anything like that, we optimize that bandwidth. We've done a lot of work on that to make it work well. I think if you ask around, you'll find out we really have the best remote capability in the business. Another thing we can offer is multiple receivers. So as I mentioned back talking about a direct sampling SDR, we can have multiple of those. Most radios you buy have 1 or 2 receivers in them. Our high-end radios have 4 or 8 receivers in them. And so there's a lot of things you can do with that. If you're a let's say you're somebody that chases FT8, you could pull up 4 bands of FT8 at once, watch all 4 of them, and then keep that in sync with your DX log. And when you see somebody pop up on any one of those 4 bands, you just click on them to work them. So that's something you can do with our radio that you can't really do with other radios. We also take the audio and the control from the radio, and we encapsulate those over Ethernet and send them to your computer. So a lot of radios, you got to put an external digital interface on and Reptoids around it to keep the RF out of it and all that kind of junk. With our radio, all that travels over the Ethernet cord, so you don't have to worry about any external interfaces or anything to do digital electronics, digital communications. So this is a panel called the Digital Audio Exchange. It takes the receiver audio out of each of the receivers in the radio, turns it into an Ethernet signal, sends it across to your computer, where we kind of reconstitute it into a sound card, virtual sound card. So then you can point your sound card audio programs at that and connect directly back to the radio, and it's all transparent. We also do the same thing for control over CAD. We do the same thing really with serial ports. There are no serial ports on the back of the radio, but we have 2 USB ports. You can plug into those USB to serial, put as many serial control cables on the outside of the radio as you want. There's an API that's available to work the radio over the Ethernet, so there's a whole lot of flexibility in the radio. Now, I told you about bandwidth and the things we did to optimize it for remote. This is just an example showing you what we've done. If you look at streaming audio from the receiver, that can vary from 70 to 200 kilobits depending on how you have the receiver configured. You can turn the pan adapter or the spectrum display down to 1 frame a second, and it only takes 70 kilobits worth of data. So within a couple hundred kilobits, you can transmit the whole radio and operate the radio. So if you're on a very bandwidth limited connection like a cell phone, you can do that. You can also turn up the PAN adapter and turn on DAC streams and all kinds of stuff and run the bandwidth between the radio and the computer up to 20 or more megabits if you're operating locally and you want to do all that and see everything and do that kind of stuff. But it is completely under your control how much bandwidth you use. We also have SO2R and full duplex capabilities inside the radio. Why do you care about that? So SO2R allows you to run one operator with two different radios. So you can sit there. The typical mode of operation is you'll call CQ on one radio and you'll go over and work somebody who's answered your CQ on the next radio while somebody's calling you over here, and then you toggle back and forth. So you're always transmitting on one radio. We can do that inside of one radio. So you pick two different bands and you alternate your transmit. Because the radio is full duplex, you can listen on the other band, and you can operate single operator two radio, but with one radio. So if that's something you want to do, you can do that with half the equipment that you would in any other radio. We have industry-leading phase noise. Phase noise is kind of an esoteric topic, but what this allows you to do is operate close to other operators in a field day or contest situation and not bother the people as much as you would with other radios. And the other thing that's really nice about us is that we are vested in continuous improvement. If you look at somebody who's bought our radio back in 2011 or 2012, the functionality is, it's this much when they bought that radio, but we've added to it and added to it and added to it over the years, and there's a tremendous amount more that you can do with our radios as you continue to own them. So we don't think about a radio as something that you buy and what you get out of the box is what you're always going to have. We say that's the starting point, and then we add stuff to it. We charge a nominal fee for the upgrades, so you have to pay for some of those software upgrades, but we've added a lot of stuff over the years. So this is a note to tell you, like in 2012 when we first introduced the Flex 6000, it didn't have any of these features that I'm going to talk about, but all these were added in software later. You didn't have to buy any extra hardware to get them. So we added the DACs, we added waterfall, synchronous AM, tracking notch filter, quick record playback, downward expander, speech processor, FM remote and LAN. That was in the second year after it was introduced. Then we did WAN remote, Maestro, API release. So you go down this list. I'm not going to bore you with the whole list, but we added feature after feature every year. And so this is kind of what we do, what we're invested in. One of the things that happened as we added all those features over the years is that we ran out of space in the Flex 6000 to add more features. And so, at the time when we built the radio, we built it with a lot of extra space in it, but we filled that stuff up over the next 10 years. So what we've done now is to introduce the Flex 8000 series. And the main things we've done with it, we've done some things that, well, I'll kind of go through the list here. We added about 4 times the processing power. We added a much larger FPGA in it. We added a GNSS receiver, so your radio is always on frequency. You don't have to tweak any knobs or do anything with that anymore. We added a sampler, so you could put adaptive predistortion in. So there's a number of other hardware things, but adding the processor size and the FPGA was the thing that we really did, because now it gives us a new platform to go fill it up with all kinds of new software features, which I'll talk about a little bit. We offer 4 base models here. We have an 84, an 84M, and then an 86 and an 86M. The fundamental difference between the 84 and the 86 is that the 84 can talk to 1 antenna at a time, and the 86 can talk to 2. The 84 has 2 receivers, whereas the 86 has 4. So if you only have 1 antenna and you think you're only going to ever want to listen to 2 bands at the same time, an 84 is the radio for you. If you have more than 1 antenna that you might want to listen to at the same time, and the idea of having 4 receivers so you could work 4 bands at the same time appeals to you, because like on FT8, that's a really great way to operate, then an 86 is probably what's more interesting to you. The M on the end just says whether or not it has the control panel with the screen and the buttons and knobs on the front, which I'll show you what that looks like in a minute. So you kind of get your choice of all these, and there's sort of the features that are in them. Any questions about this? I know I'm kind of galloping through this, but I don't want to bore everybody with stuff that you may have seen before. So these are the things, some of the things that we've done in the Flex 8000. So we built everything on top of the existing 6000 line. So if you have a 6000, it's completely familiar. Every way that it operates is basically the same. But again, we've added the capability in it to do more things. As I mentioned, there's enhanced performance. We also, if you buy an M series, we've doubled the performance of the M panel as well, so that's a nice thing. We integrated the GNSS receiver, which, as I mentioned, gives you the ability to be on frequency continually, so you don't ever have to worry about that again. We also have an optional GPS DO if you want to put in the radio, which has a 10 megahertz output. So if you're a microwave operator or you have test equipment in your lab or anything like that you want to run off of 10 megahertz, you can do that. The back of the radio looks basically the same as the 6000. There's a few things moved around. At the top here, we have a GNSS antenna connection. There is a space here for serial data in and out. If you have a DB25 with serial data, nobody in here has that, I'm pretty sure. We use that for the military. You don't want to use that. So we pulled it out of this radio. There's a display connector there, which is populated if you have an M series. So you can plug an external HDMI monitor into it and put it on a big screen. We've got a 10 megahertz out and a 10 megahertz in location. These are now both BNCs. Before these were SMA connectors, which really isn't standard. BNC makes more sense. And then we have the other antenna ports on here. So there's those only exist on the 86, and the rest of the antenna ports are on the 84. So on 84 you get 4 antenna ports, on an 86 you get 6. The internal GNSS receiver is a 32-channel multi-system capable L1 GPS. Time to first fix is 35 seconds, so it's a modern day GPS. It does have wide area augmentation on it as well. These are the systems the 4 systems that it tracks. So it's the American, Russian, European, and Japanese systems. So it works with any of those set of satellites. If you have an interest in wide area augmentation, these are the systems that do that in each country. So it will also receive any of these. I don't think you really care about that. Frankly, once you've got satellite lock, you're going to be on frequency. Any questions about the 8000 before I move along? I'll get into software a little bit later.
Does the satellite lock include keeping the clock on?
Yeah, it's a GPS satellite lock or to one of the other GNSS systems. Yeah.
The clock in the radio is always synchronized.
Yeah.
Not just the frequency of the radio.
Yes, yeah. So there's a single master oscillator in the radio that goes to the receiver and the transmitter, and that master oscillator is locked to an internal 10 megahertz reference. If you put a GPS receiver in there, which we did, then the 10 megahertz is locked to it, which means the whole thing is locked to GPS.
Right. You have a time display.
Yes, there is also time available in the radio if you want to see the time. Yeah, you can output the GPS sentences and see the time if you don't see that. It's not a separate clock chip, no. It all is derived from GPS. Yes? Yes, the software to access the radio is forward and backward compatible. So you have to have version 3.8 in order to connect to an 8000. So if he's currently using an earlier version of 3, he won't be able to connect to a new 8000. He just needs to upgrade. If you upgrade, then you're at least at 3.8 or better. You can operate on any of the radios. It doesn't matter. That's right. Yeah, the software is the same. It knows when it connects to the radio which radio it is, and it displays panels differently based on any features that are different in the radio. Other questions? Okay, the other thing that we did last year was we introduced a new Maestro. This will be our 3rd generation Maestro. We did a lot of work on the Wi-Fi capability to improve it, so it's now Wi-Fi 6 compatible. It has a MIMO antenna in it, which allows it to be moved around and get better Wi-Fi capability. The CW side tone wasn't great in the prior Maestro. We fixed that. It sounds great in the new one. We added the older Maestros had a rechargeable battery option, but you had to go buy an off-the-shelf battery and put it in there. And it wasn't really that well integrated. We did that because we felt like we wanted customers to be able to buy an inexpensive off-the-shelf battery and do that. But there were issues with that. So we went ahead and put a rechargeable battery in there that's off the shelf. You get about 8 to 10 hours worth of runtime off this battery, which is really great. It's a 99 watt-hour battery, and it's roughly the same size as one of these batteries. So it's a pretty sizable battery. That's also a 99 watt-hour one. We changed the power switch so it looks the same as our radios. We added a new pseudo-differential mic connection. There is now HDMI output on the Maestro. We didn't have that before. So if you're operating in a shack, you want other people to be able to see it, you can put up a big display and hook that to HDMI. We also combine the headphone out and the microphone, so it's in a single CTIA connector, which is the same connector that Apple used to use before they went away from using the connector. But it lets you use one plug for the headphone to plug in the headphone and mic. And then we put a 24-volt DC charger on here. We would have loved to do 12, but the 24 allows us to charge the battery inside of the Maestro, so you can do that now. The Maestro looks fairly similar. The power button looks a little different, but most everything else looks similar. This is a location on the back where the battery goes. We've moved some of the controls. If you have an older Maestro, some controls are on the left and some are on the right on the back side. These are now all on the left side of the Maestro, and I'm not going to run through all these, but that's kind of all the controls there. The battery that we're buying is it's a battery that's designed in Germany, and they're readily available in the EU and the United States and all that. So you don't necessarily have to buy them from us. If we're out of stock, you can buy them from Mauser, or you can buy them from a number of distributors. They also offer a single bay 60-watt charger you can use, or a dual charger. So you can buy those from us. You can buy them on Mauser, on the internet, whatever you want to do. I do not recommend buying the battery from a third party. I recommend the batteries are made by RCC, and I would recommend buying their battery, not somebody else's. Somebody's bought some Chinese knockoff batteries and they have not worked. So I don't know what the story is on all that, but I wouldn't buy the knockoffs. This is the pricing for the Maestro, the battery, and the chargers from us, and the battery and the chargers pretty much the same price as you can get them on the web, so wherever you want to buy them. We don't really make any money on them, so whatever. It does not. The Maestro, if you buy the Maestro for $15.99, it doesn't include the battery or the charger. The battery and the charger are options.
How about the legs?
What's that?
The legs.
So the Maestro comes, one of the things we did when we built the very first Maestro is we had legs that fold on it, and we took the Maestro and set it in front of a bunch of people and said, adjust the Maestro where you want to operate it. And they all set it within a few degrees of each other. And so we went, okay, we're going to build a fixed leg and offer it at a lower price with that fixed leg. So the bulk of everybody will be able to use that and have it where they want it. We also offer legs that you can completely adjust and lay flat. Those are, what are they, Mike? 99 bucks or something? Yeah, they're $99 if you want the adjustable legs. So whatever one of those things you want to do.
Use the old one from the 6,000?
Can you use the old ones? Yes, they're the same ones. They're the same ones, yeah.
The Maestro and battery, it doesn't buy the external charger. I believe the charge, Maestro, one minute, the battery,
So the question is, has a Maestro with the battery and the external and the charger inside the Maestro, but nothing outside? Can you leave it plugged in? Will it affect the battery life? I believe the answer to that is no. The charger that we use is built by the same manufacturer of the batteries. They're designed to be run that way. I don't think that's going to hurt your battery life. They are lithium-ion batteries, and so I think every now and then you should run it down and run it back up. You know, every couple of months or something. I probably would do that. It's like any typical lithium-ion battery. They don't like to be run all the way down and all the way up for thousands and thousands of number of cycles. Batteries, it's probably 500 or 1,000 cycles you can get out of them. But again, the charger, both internal and external, is made by RRC. You can look them up and look at the data sheet on them. I don't remember the details on top of my head, but they've been doing it a long time. The real reason we use them is because if you take one of the batteries and look on the back of it, there's like 25 certifications for each different country that you have to have in order to ship it to all these different countries. And it would have cost us a fortune to get the battery certified in all those companies. So it was easier to buy a battery from somebody who's already gone through the trouble. Other questions before I go on? Yeah.
You've already ordered a Maestro and it's on the way. It obviously didn't come with the battery. Will it operate?
Yes, it operates without the battery. Yes. You just plug it into the supply and you operate it always on the supply.
It runs on 24 volts supply?
It runs on 24 volts, yes. And it comes with the charger.
Oh, okay.
It comes with the external adapter. You know, it's a typical brick with a line cord on it and all that. It comes with that. All right, so let's talk about software features. So 3.8 is the first release we have that supports the 8000. So you can't go any further back on an 8000 than 3.8. We added squelch for all voice modes in that release. 3.9, which is currently an alpha test, we've added TGXL and PGXL integration. So if you have an external PGXL and tuner, all that is now integrated in SmartSDR, and I have some pictures to show you that. We added analog meters. It's kind of a skeuomorphic design that shows you an analog meter instead of a digital one. We added USB serial cable pass-through. So if you have like a rotator that operates with serial commands, you can plug a USB to serial cable in the back of your Flex 6000 or 8000, run that over to your rotator, and then on your computer that you take remote and run on SmartLink, let's say you're in the next state over, you can run your software, your rotor control software on the same PC, and then point it at a connection that you create in CAT, a virtual serial cable, and then you can talk to your rotor completely through the Ethernet, and we package it and send it all the way, and it pops out on the other end. So it allows you to operate any serial device remotely over the same connection using SmartLink. Does this make sense? Any questions about that one? We've also added adaptive predistortion, and which I'm going to talk about and explain what that is, and we added an integrated two-tone test vehicle. I'm not going to spend a lot of time talking about the PGXL and TGXL, but the PGXL is a 1500 watt amplifier, and the TGXL is a 2 kilowatt tuner that allows you to operate with that and tune it to your antenna. But I will show you what the integration looks like. So there's a new panel for the Tuner Genius integration, the TGXL, and there's a tune indication down here at the bottom. So this is what the panel looks like. It's got your forward power, SWR, and then on the bottom, it's a CLC, so it shows you the settings for the capacitor and inductors, and you can put it in bypass. So to enable the bypass, you can click and unclick the tune button down here, and it'll put it in bypass. And then we did the same thing on the Maestro. There's a tune indicator up here on the Maestro, and then there's new meters for the SWR and power out. Yes? The Tuner Genius, for this operation, you'll need the Ethernet cable to operate it. Yeah, it has an Ethernet connector on the back. You'll need to run it to Ethernet. Yeah, the Tuner Genius can be operated without that using BCD control or something else on a different rig. But to get this, yeah, you need the Ethernet. There's a setup panel that shows you more detail and shows you what IP address it's on and all that sort of stuff. All right, analog meters. So we've added analog meters in both receive and transmit. There's a transmit function that you can drop down and select what you want it to show while it's in transmit. So here you can see power, SWR, microphone. Let's see. Yeah, so here's what it looks like. This is before we added ballistics to it, so it looks kind of jerky, but we've added ballistics to it now, so it looks more natural. And as you select the different meters, it shows you what they look like, and then in the upper left corner, it shows you which slice it's metering, and on the upper right-hand corner, it also shows you the S meter reading in dBm or S units if you're in receive. This is also available for the 6000, yes. In general, anything that we have the capability of doing on the 6000 will also release on the 6000. This is primarily a GUI function, and so it's not a big deal. We released it on the 6000 as well. What's the question? Yeah, 3.9 is not out yet. It's in alpha test, so it'll be out soon. Can't hear you. Yes, at the current time, all we do is charge for major releases. So going from 3 to 4 is a charge option. If you have 3.8, going to 3.9 is a no charge option. All right, this is analog meters on the Maestro. I'm not going to spend a lot of time showing you this, but it's the same kind of thing that's on the rest of the radio. All right, I'm going to spend some time now talking about the 8000 software roadmap and where we are with that. So again, as I mentioned earlier, we've added a lot of processing power in the radio so we can add new features. And again, anything that requires either hardware functionality we put in the 8000 or the processing power that does not exist in the 6000, we're unable to release on the 6000. Okay, one of the first things that we're going to release is adaptive predistortion. So I want to explain a little about what that is and why you care about it. So intermodulation distortion occurs, and it's caused by nonlinearities in our linear amplifiers. So if you look inside a radio, any radio, not just ours, there's typically an exciter, and the exciter produces a very low level output on the frequency of interest, but it does not have the amplification on it yet. It's very easy to build an exciter that's very, very linear and doesn't produce much intermodulation distortion. However, a power amplifier, you have to spend a whole lot more money to make one very linear. And so the default position most people take is we're going to make it fairly linear, but not completely linear. And so what happens is the amplifier will generate products depending on what kind of signal you put through it. So this is an example. This is a spectrum view, what's called the two-tone test. So we're generating two tones that are fairly close to each other in frequency. And what happens on something like this, these we would call the fundamentals, is we end up with these products. And these are called intermodulation products. And I'll explain to you kind of why this happens. But this is something that we really don't want, because if you're, this happens when you're talking on sideband, for example, and you're going to generate this other noise that's going to be outside of your passband. And it's not a nice neighbor thing to generate that noise. So we'd like to get rid of it. The products that are closest to the fundamental are called third order products, then there's fifth order products, and so on. This isn't just a ham radio problem. This exists with any kind of linear amplifier. This is an example in the cellular market of this happening as well. So the blue signal here is the exciter waveform, and this is what we call professionally in the world of radio as a Bart's head. You know, the signal goes up and it has, you know, all these multiple carriers and then comes back down. So this signal's fairly wide. I think this one looks like it's 20 megahertz wide. But what you end up with is this extra stuff on the side, which is the red that's above the blue. So it's this stuff here. All that extra signal. In the cellular world, they call this spectral regrowth, but it's also just intermodulation distortion. Spectral regrowth. Spectral regrowth, yeah. Is that right, Mike? Yeah, okay. All right, in the FCC rules, Part 97307, there's emission standards, and it actually says the station transmitter must be reduced to the greatest extent practicable. So anyway, the FCC says you want to get rid of this stuff if you can. If you can't, you know, you can't. So I want to explain why this happens and what we can do to fix it. So we're going to take a fictitious amplifier here and show you how it works. On the x-axis here we have power in, and on the y-axis we have power out. And this horizontal line is our ideal linear amplifier. And so what happens is if you put in 1 watt, this is going to be a 10 dB gain amplifier, we'd get 10 watts out. If you put in 4 watts, you get 40 watts out. If you put in 10 watts, you get 100 watts out. That's a perfectly linear amplifier. This is not the logo for Cessna, actually, but this is what actually happens, this yellow line. You can see it kind of sags on either end, and especially on the upper end. And so what happens is if you put in 10 watts, instead of getting 100, you might only get 95 out. That's called, in the industry, it's called compression. And if you go pick up any linear transistor and look at it, it's going to be rated in either P1 dB or P3 dB. P1 dB is how much power you can put into the transistor before it exhibits 1 dB of compression. In other words, the power that you get out is 1 dB below what you were expecting to get out given the gain. P3 dB is the same thing, but you get 3 dB power less out. Okay, so how do we fix this? Well, one option is running full Class A, and in general, if you're going to run full Class A, you got to put a lot more power into the amplifier, you're a lot less efficient, you got to put a lot bigger transistors, so it's more cost, more energy, more heat. It's not really an optimal way of doing it. But if we knew exactly how that signal would be distorted, so if we knew that every time we put 10 in, we got 95 out, could we put in 11 or something to get 100 out? In other words, we would distort the signal on the front end in order to get the signal that we wanted on the back end. So that's essentially what predistortion is. We calculate the input signal level that gives us the desired output signal level, and that's what we put in the transistor instead of what the exciter generated by itself. So in order to do that, we look at every voltage going into the amplifier and we make that adjustment on it. Okay, so there's a lot of different ways of doing predistortion. You can account for just voltage differences. You can account for temperatures that change in the power amplifier. There's memory effects from the heat in the heat sink staying there, and even if you've reduced the current to the amplifier, there's all kinds of things you can do. But kind of the two big categories are either static and adaptive. So in static predistortion, you do some kind of a basic calibration, and then you store that calibration, and then you just use it. And you don't look at anything else going on over time. And you can see typically 8 to 15 dB of improvement doing something like that. So this is, you take your radio, you would calibrate it once, you store the calibration, and then you operate. And if the transistor heats up over time, it may not work quite as well, or if the condition changes in your power amplifier or anything like that. In adaptive predistortion, we look at the spectrum in real time. So as we're transmitting, we watch the output, we feed that back to the input, we make an adjustment, and we continually adjust essentially the mapping of what we should be sending out in order to get the right output, and we tweak it continually until we get it right. And so adaptive continues to change. So as the radio heats up or other things happen, it continues to give you good improvement. And you typically see more improvement, 15 to 25 dB doing that. So what we've implemented in our radio is adaptive predistortion. So it dynamically characterizes the PA performance and builds the correction model in real time, and then continually reapplies that correction model. So we have this working in the lab. I think we're going to release it in the next month or two, and it's actually an alpha test. We have a number of people that are testing it. It is today only going to be available on all the Flex 8000 radios for a couple of reasons. One is we built a sampler into the radio to make this work better, and the other one is the CPU performance that it requires to continually calculate the adaptive matrix really requires the power that we have in the 8000. The most common question we get about this feature is, are you going to make it available in the 6000? So the software in basic radio exists to do this. What we really need to do is have some external processing power and an external sampler. We know how to do it. We're thinking about doing it. We're not 100% sure if we're going to do it or when we're going to do it, but it is very possible. So we're investigating, and more to follow. Okay, so this works with both the internal 100-watt PA, but you can also get it to loop with an external amplifier as well. Let's see. The PGXL that we sell has an integrated sampler as well. So let me show you the different mechanisms that we can use. On the left-hand side is at 100 watts, you're standalone. You just stick an antenna on your 8000 and you can use predistortion. You can also connect it to a PGXL. You take the sampler output, run it back to a receiver port on the radio, and you can operate that way. Or with a third-party amplifier, we're going to provide a sampler that you can feed the signal back into the radio, and it also releases the antenna port from the radio. So you could also use the sampler with the PGXL. So we have that designed. We haven't released it yet. So the final option here, the last option, we don't have yet today. We've tested it, but we don't have it available. The first two are available today. So let me show you. This is a video. Yes? So the 100-watt PA in the radio is also a linear amplifier that has nonlinearities. So what I'm about to show you is a recording that Michael back here did he has an 8000 and a 6000. He's using the 8000 for the transmitter and a 6000 for the receiver. The 8000 is going to be on the right-hand side, and he'll turn APD on and off and show you what it looks like on a sideband signal.
I'll turn adaptive predistortion on, and we'll go into full transmit 1, 2, 3, 4, 5. You can see that we have these spurs up and down here, and those are the what we don't want, and it's all about the cleaner signal. Now when I turn on adaptive predistortion, you'll see they disappear, and we lose most of those spurs, and that is a much cleaner transmitted signal. This is our beautiful column waterfall showing adaptive predistortion while it's being functioned. Adaptive means, of course, that it's always adapting. If I was to change frequency, or the RF levels would change, or something to that effect. As you can see now, I have turned adaptive predistortion off. We're back to having these spur products, and when we flip it back on, they actually disappear. So that's adaptive predistortion on a Flex 8600.
Okay, any questions about APD before we go on? Yeah.
Yeah, when is option 3 going to be available? I'm using my 86, I'm using the third party.
Yeah, so the question is when are we going to have a sampler, external sampler available? I don't know the date yet. We don't have it all planned out. It'll probably be later this year. I'd probably guess third quarter. Is there a sample port on that amplifier?
I don't think so.
Okay. Yeah.
If there is, doesn't that make it easier?
If you have one, you should be able to run the sample port back to the radio and use it like that. It will tie up a receive port on the radio, so you'll lose a receive port, but that is another option you can use. All right, let's see. We got about 20 minutes here, so I've got about 10 more slides for other features, and then we'll take questions. So this is a plot from Club Log of different modes, and the red mode here is FT8. All the other modes are the other colors. And you can see when FT8 was introduced, it became the dominant mode that everybody's using to make contacts, at least for DXing. And so the problem with this mode is that everyone is scrunched into 3 kilohertz of bandwidth. You know, here's the 20 meter band, and everybody's scrunched into that area, and we have lots and lots of other bandwidth to use. So with the 8000, we're going to introduce what we call amateur wideband, which is the ability to transmit and receive over a 40 kilohertz area, over 40 kilohertz of bandwidth. So we'll even allow you to transmit multiple carriers in that 40 kilohertz with a single radio. And this is before any changes are made to WSJT or any of the other FT8 software. Now, this may be something after we do this that they decide they want to change and allow you to do it in a different way, but this is something we're putting in the radio. So we'll take the 3 kilohertz window that you can use and move it into 40 kilohertz. So if there's other people that are transmitting there, you can talk to them. If they're on a flex, you can use any amount of that space that you want. You can be anywhere in that area. Let's see. That's just in the 8000, yeah. And we will, the software works to guarantee that you're doing the legal thing. You can't take a 40 kilohertz single signal bandwidth and transmit it out of your radio. We won't let you do that. That's against the rules. But you can transmit multiple single tone things that are within 3 kilohertz bandwidths within that. Okay, so this is what we're going to do is give you that much space, so it's 13 times the space to go do that. You'll be able to operate more than one carrier in that bandwidth at the same time. Yeah, so you could work multiple people at the same time. Yes, you'll be able to work FT4 and FT8 at the same time using that. And decode at the same time, yes. Yeah. You'll have to use 2 instances of WSJT to do it, but you can do that, yeah. We're essentially going to spoof it to make it look like it's 2 different radios to the software. Okay, another feature we're going to add in the 8000 is what we call spectrum overview. So you'll be able to get visibility of the whole HF spectrum and 6 meters or any particular bands that you want in a single pan adapter window with a noise floor that's much less than you'd see today. So if you look on a typical spectrum analyzer or a radio today and you begin zooming out, looking at more bandwidth, your noise floor goes up as you do that. And what we've built inside the radio is the capability to keep the noise floor low and look at an entire band at the same time. Not only that, but we're going to stack multiple bands next to each other in a display that lets you see multiple bands. So if you want to watch 10, 15, and 20, and 15 and 20 aren't open, but you want to keep an eye on them, you can do that with a single pan adapter window without using a bunch of your extra resources in the radio. So you won't have to use 3 receivers in order to do that. We have some advanced noise reduction capabilities we're going to put in the radio that need more CPU power. We've already added an integrated NTP server. So because we have the GNSS receiver in there, it has an NTP server. This means you could go into the field and run WSJT, which is a time-sensitive application. You can point your computer at the radio and say, that's my time server, and it will serve time over NTP for you. So you don't have to have some other kind of time source. This is the pricing on the radios and kind of a feature checklist. The things that are O's are optional. The things that aren't there are things you can't put in, and then the check marks are what's standard. I'll come back to this slide in just a second so you can get a chance to look at it. We're shipping these radios now. We're currently shipping from backlog. We got a whole bunch of orders when we announced this back at the Dayton Hamcation, and since then, we expect to be completely through the backlog by the end of May. So or by early May, maybe the end of April. So if you ordered today, that's about the time frame you'd get a radio. And if you've ordered already, you can please wait for us to contact you because we got a lot of orders we're going through. If you want to purchase one today, it's a $500 deposit, and then we'll get the rest from you when the radio's actually shipped. And certainly you can order it in the booth. We also you can contact us by telephone or call or send an email to Andy or sales@FlexRadio. Okay, I'll go back to this, and then I'll take any questions. Yes?
I think I saw on your website you had an upgrade board for 6,000 to 8,000. I don't know if I understand. It's like about $800.
The question was, is there an upgrade board to go from a 6,000 to 8,000? The answer is no, but we do take trade-ins, so you can trade in a 6,000 on an 8,000 if you want to do that. I think we're the, yeah. All right, thank you all.